everyone. Welcome to today's webinar. I can see that we have a full house. People are still trickling in, so excited to have everyone. And I'm particularly excited to be able to have Shir Chorev from Deepchecks today as our guest speaker. My name is Andrea, and I'm a project manager at Weights and Biases, and I will guide you through the webinar. And today's topic is how to test and validate your machine learning models and data. And also, we'll see a live demo on how to use two powerful tools, namely Deepchecks and Weights and Biases together. And I'm going to introduce our speaker, Shir, or our speakers, Shir and Morgan, in just a second. I'll just quickly run through today's housekeeping and what to expect from the upcoming 60 minutes. So we'll hear a bit about the founding stories of Deepchecks, their vision, and we'll also see a live demo. So bear with us, and we will share the links for you to participate live. Please use the Q&A or join the conversation tab on your right-hand side. We'll try to address any questions or comments you have during the webinar as well at the end, where we have time reserved for a Q&A. So what is it that you can expect from today's webinar? We're going to look at different types of models, different types of problems that machine learning models face. We'll cover best practices for validation, when, how, and what to test for. And like I've mentioned, we'll then dive into the live demo of using Deepchecks open source package for effective validation and present the recent option to integrate the validation results with weights and biases. And now let me just click to bring Shir on stage. So welcome. We're very excited to have you. Shir is the co-founder and CTO of Deepchecks, an MLOps startup for continuous validation of machine learning models and data. She's previously worked at the Israeli Prime Minister's office and at Unit 8200, where she was conducting and leading research in various machine learning and cyber-related problems. And she holds a Bachelor of Science in Physics from Hebrew University and a Master of Science in Electrical Engineering from Tel Aviv. So welcome. We're excited to have you.
Hey, thank you. Excited to be here.
Awesome. Now let me also bring up my colleague, Morgan. Hello, Morgan. Morgan is a growth machine learning engineer at Weights and Biases, and he has a background in NLP and has previously worked at Facebook on the safety team, where he helped classify and flag potentially high severity content for removal. And with that being said, I'd like to hand over the stage to you guys and to get started.
Brilliant, cool. Thanks, Andrea, and welcome everyone. Delighted to be here. So I'm hopefully going to do minimal talking here. We're really excited to hear from Shir and the Deepchecks library and get a little tour and a demo. Yeah, Shir, do you want to kick it off? Like up to you. If you want to maybe give us a little background on, you know, Deepchecks, the library, and kind of like how it started, and maybe your, like, if you want to throw in a little bit of your journey as a founder and CTO.
Sure, I'd be happy to. So, yeah, start maybe a bit more with like my experience and what initially brought us to Deepchecks and the field in general of monitoring and validation, and then dive in a bit more into the library. So as Andrea also presented, in the past 7 years, I've been in the field of data science, initially working on various projects for mainly for anti-terror use cases, and something that, well, we met quite a lot there, and also Philip, my co-founder and colleague, and well, also additional friends in the field of machine learning, we understood that while the algorithms are challenging and interesting, lots of the challenge, and well, I mean, today it's really common knowledge, but lots of the challenges are in everything around it, like in the MLOps area and bringing your model to production and serving it. And one of the things that we felt were very close to heart is also in how does it actually operate over time. So we did see quite a lot of projects, mainly in like more initial phases that you think you're ready, and then suddenly you understand that live data doesn't behave as you think it should, or different performance issues. And that was in general what brought us to deal with the area of monitoring and validating machine learning models and to found Deepchecks. And well, while working in Deepchecks with various customers, mainly in production-related areas, we noticed that many of the problems that we find in production, whether they're related to data integrity or to even to model evaluation or to different changes that happen, many of them could have already been detected previously, like before they were actually deployed. So that was quite a big understanding that that we thought we thought, first of all, that's one of the things that led us to delve more into the area of what can or should you do when you actually test and validate your model offline. And that's what I'll talk a bit about more, like how we see it, what types of checks, and how is this all connected. And in general, in Deepchecks, we look at the concept of, well, you can say like continuous validation, in which for us, it's starting from the first time you meet your data. So like you're not really yet testing anything, but you are kind of always verifying that what you're working on represents what you think it is. So that's so kind of Deepchecks is, I would say, from the time as a data scientist you meet the data till you already have an initial model, a more mature model, and well, later on for production monitoring, that's it can also be used. And we also have like that's more the enterprise side of our offering. But the open source package is for everything that you can do in the research phases.
Cool. Love it. Super interesting. And yeah, I would love to talk about the life of a open source maintainer as well. I'm sure there's a few good stories there as well. But yeah, would love to hear. Yeah, maybe you could give us a quick spin through Deepchecks and kind of show off some of the bells and whistles.
Sure. So in general, I'll say that we are, well, as Andrew also said, we're going to see a live demo, which you're welcome to run it as we go through it. So you'll have the link for the notebook, and it can, if you have like basically you need to install Deepchecks with pip and weights and biases as well. You can also, but anyway, you can, like, if you want, you can try already checking that you downloaded it if you want to follow through, but we'll get to that a bit later. I'm just saying that to give a heads up. What I'll do is I'll talk a bit about generally the concept of model and data validation, what does it mean, and a bit about our like plans for the future and how we see this evolving. And after we get like the general idea of what we're talking about, then we'll see it in action. I will say that I'll be super happy to get any questions, thoughts, clarifications also as I talk. So feel free to, like, you don't need to wait for the end or something like that. Cool. So let's go. 1 second. Okay. Yeah, so in a sec, the slides will be up. Great. So, well, we'll talk in general about model and data validation. We do see that these things are intertwined, and the Deepchecks package really tries to follow through the whole journey. So, well, being data scientists, this area of the fact that most of our time is spent on everything that is around the model, whether it's the data collecting, preparing the model itself, evaluating it, and a small amount of time relatively is on building the model, we felt that it is quite surprising that there aren't actually any, well, not any that we're familiar with, tools or methodologies to actually validate it in like any frameworks or any common ideas. I think it's also due to the fact that it's a relatively new field. So if you look at the area of software development, then there's quite a variety of both the philosophies and also practical tools. But in machine learning, we felt that, okay, the monitoring, everyone understands that it's important, and people understand that you want to evaluate your model properly, but how do you do it, or how do you make sure you do it comprehensively? So starting with a quick overview, we try to understand what do you actually have to check. And well, obviously, one of the challenges is that when you have something that you're not exactly sure how it works or what does it represent, the main challenge is making sure that it represents reality as you go. So you have the data that you collected or that is ongoing, like that is in streaming and coming throughout your system. And well, the interesting question in that area is, does the data represent what I think it does represent? Are there any integrity problems or distribution changes? Is the data relevant? Like maybe there are some irrelevant features, or there's a specific leakage that I'm not aware of. There's the method, which is everything that has to do with the process with machine learning. So, for example, when I split my train and test, did I do it in a stratified manner? Do I have maybe some leakage in that phase? Things that have to do with the way I train my model, like overfitting and anything in that area that has to do with what I actually do. And of course, the model itself. And seeing as these areas are quite intertwined, when we look at the process of validating your machine learning, so we look both at all of these and also at the connection between them. So after the high details, what are we actually talking about or looking for? So try to kind of group all the different types of problems into specific groups. So we have here things that have to do with your data. This is the titles, and we'll see a few of the checks soon, and we'll understand how it actually looks. But in the area of data integrity, you have data duplicates, dirty data, inconsistencies, maybe same samples with like different labels, or just something that is behaving weird. Maybe it's because of the data source, maybe it's because of the way you collected it. We have things that have to do with, as I said, the methodology. So leakage, sampling, overfit, the way you select your features. Things that in some cases are relevant that have to do with fairness and bias constraints. So does my model behave in the same manner in different areas, for example, for different demographies? Things that have to do with model performance, which of course this is like super basic. I mean, the first thing you do when you have a model is you evaluate it. But in what way do you check the different subsegments of the data? Do you continue checking it over time? Do you make sure the probabilities are calibrated, and do they actually represent or do they, how accurate are they in representing the, let's say, the real probabilities of the way things behave in the real world? And of course, things that have to do with changes or weird stuff with data, which is more in the area of their distribution, so not necessarily data integrity. So, for example, a drift, or it can be concept drift or data drift. And looking at all these types of issues, and as I said, we started from the area of monitoring, but well, we thought, wait, things like data integrity or things like in my methodology or a weak segment is something that I don't actually have to wait. So I'd say that our short answer to this question of when should you validate is as early as possible. So if we look at a kind of generic pipeline of machine learning validation, when does that mean? So in the first time you meet your data, and you already have something to work with, maybe the labels, but still not any model, you can already check out and look at your data itself and explore it and validate it. Once you've started modeling, whether it's, again, your first iteration or already a more advanced model, or, by the way, also when you've retrained your model, whether you did it manually or as a part of an automatic retrain, you can thoroughly evaluate both the model itself and also things that have to do with the data, like how the data changed over time, or between your train and test, or maybe even between your previous train and your new train. And well, once it's deployed, then of course the area of monitoring is relevant to kind of make sure that things keep going. And, well, it kind of looks as though we're talking about a line and you advance throughout, but of course both things like a retrain or new data coming continuously. So whether if you're in the research phase or if the model is already in production and you're either working on a new version or it's retraining, it's not something that we meet only once in the life cycle of the model. So we felt that even for a specific project, it's something that we tend to come back to at a specific extent, not necessarily manually. So this is, I'll say that one of the things that we were really thinking of is how or what are the things that are common and what can we automate? So the concept of how can we give a framework that will enable adoption of more efficient, comprehensive, and automated testing. So, well, this is we're going to talk about everything that has to do with the left side. Of course, monitoring is relevant and interesting as well, and feel free to reach out to me for that if you have some additional questions. But it's less in the area of the open source package, currently at least. So we decided to release this open source because we felt that everything that has to do in the process of the research is something that you're doing in a setting in which you want full control of what's actually happening. You probably want some custom code of validating your own stuff, and you probably want to run it locally. And in general, we felt that it's relevant for a lot of use cases, probably much more than when you only have a model in production and you want to monitor it. So basically, anyone that is working on a specific machine learning project would want to have these types of checks or a way to do it in an efficient manner, and that's one of the reasons we felt that not only felt, let's say, that we talked with lots of people that were kind of saying, yeah, I really don't understand how this doesn't exist yet, and we're happy to see it's like we launched it just a few months ago, so it's still kind of evolving and gaining traction, but we felt that like it was received with lots of love because of the thought that, okay, I do need these things, but actually it doesn't really exist yet. So what you see here is like short kind of snippets that we'll see soon, both in the notebook setting of how we run it and what we see and how does it help us, and also in the weights and biases platform, which is the integration that we've recently launched. So in order to concretize a bit, we'll talk a bit of some of the checks. I will say that currently, like actually this presentation is in the scope of tabular data. We have just also released currently it's still in a beta version, but we've started working and have quite a few checks for computer vision. Of course, like the whole, I'd say that the approach and the structure and the way we look at it is the same, but obviously all the algorithms and the checks are very different because different metrics and different data. But so many of these are actually relevant for both, but what we'll see in this context is the demo, and also I'll talk a bit more about the tabular areas. So we talked about different types of checks, and well, each type of check is also kind of relevant in different phases. I'll give a few examples of checks I like, and we'll also see some of them soon. So label ambiguity is what if I have same samples with different labels. Maybe, well, there's many reasons that this can happen. One thing that we are actually, I think one of the first real data integrity problems that I faced with in the beginning of my career as a data scientist is that we were stuck on a model that we couldn't get it like better than 85% in accuracy. It was binary classification, and we tried different types of modeling approaches. And then when we just took a bigger bunch of data and researched it a bit more and tried to find maybe some more interesting connections, we understood that some of the people in our data set were actually, there was like hidden a place that they were marked as dead people. And also they had different labels for the same kind of people and samples. So that obviously helped a lot in improving our model by dropping something like 30% of the samples. So it's a check I like also for historical reasons, and surprisingly, these things happen for various reasons. In the distribution area, well, probably here, everything that has to do with drift. So whether it's a drift in specific features, whether it's like top feature importance, or in general, things that have to do with label drift and whole data set drift is we try to find whether we can use a model to discriminate between your train data set and your test data set. And if a model successfully discriminates between them, it means that there is probably a big difference, and then we can understand how it does it and what is the reason, like what are the different features that are indicative of identifying. Of course, these are all also relevant both when you want to understand like what's happening in your data in your specific model, and also over time. So you can basically run it on any two data sets that you want to check and compare and see how they behave. So we have quite a lot of experience in that area, also for monitoring, and we've implemented the same algorithms for the open source package. In the methodology area, there's, as I said, both things that have to do with overfit. So for example, boosting, if you continue training your boosting algorithm and maybe it instead of like the performance on the test goes down in comparison to your train one. So relevant specifically for boosting models. Different types of leakages. Maybe you have the same samples between both of your data sets, or there is a problem with the dates, like you have newer samples in your training data and like older samples in your test data, which can be a potential drift of like peeking into the future and usually helping your model. And then when you come to production, you understand that something isn't behaving as you thought it's going to. Or things like sometimes you have an index that for some reason has information on the target that you wouldn't expect it to, but for in the way the data set was built, it suddenly gives some insight on that. And in the area of evaluation, as I said, this is like the basics for any model, but there's different types. For example, segment performance is checking between, in the split, so for example, looking at two features and it's different bins between them. It's the check, oh, I can't see it here, okay, so I can show it maybe later in the docs. But it's how does my model behave in subsegments of the data, so in different splits. And simple model comparison is how do I compare to a simple kind of naive baseline, whether it's a simple tree or a constant prediction, which is sometimes it's easy to train a model and say, okay, wow, the performance looks really good, but wait, a super simple model does almost the same performance, so or maybe even better, so that's actually an indication of the problem. So it's always interesting to think, what do we compare it to, and are we really implementing the best possible solution? Okay, so those were a bit of the checks, and I'll give a short explanation of the structure so you can follow. It's very simple, but so you can follow the terminology and also understand like everything that we see. So each different, like all the different, the list you see here, each one of these we call a check. And a check it receives data, so it can receive like training data or training test data or also the model. And it then has an output, so both a display output and also a result value, so that you can use like you can save it as a JSON or just use it. One is for the eyes and the other is for the machine or the code. So that's the output, and well, each of these checks can either be run by itself, for example, a drift or data duplicates, or as part of a suite. So a test suite is a long list of checks that you can either customize for yourself or use any of the built-in suites. And in order to, like, for example, at a specific phase where you want to evaluate your model, when you want to check your data's integrity, you get a whole bunch of checks. And each check can have an optional condition on it. The idea is that looking in the area, we see that validation has usually two types of purposes. One is to have a certain like go, no go. Is my data okay? Does the performance achieve the specific threshold that I wanted to? Are there any specific problems? And so that's some of the checks, and some of the checks are kind of a bit more they give you some insights that you can use to understand or further investigate for additional problems. For example, is there a specific feature? We have a check that's called model error analysis, and you can see there if there's a specific feature in which in some areas of the feature the model's error is much higher than in other areas, and this can give you some thought of how to improve the model, or maybe to find some problems in the feature engineering or in the collection or the sampling. So it's not really a go no go check, but rather something that you'd want to know, and it's not necessarily something that you check at every time. So that's the idea of doing it also in an automated manner, but inspecting it usually manually. So some of the checks can have conditions or not, and anyway they have both like the output data. And these are the things that we'll see soon also within the weights and biases platform. So this is how it looks. So the check has really like a text explaining it and some graphs or tables describing what's happening there. In this case, you see one of the checks I talked about it before of trying to discriminate between two data sets, trying to understand which one is train and which one is test, and checking if there's a drift between them as a whole. What you see here is the table of conditions. So this is like all of the checks that ran, and those of them that had conditions on, whether they passed or not. So after that, you have also like the further output for each. And in order to run your own suite, so you can, it's just a list of conditions of checks with optional conditions. So I'll maybe have this slide up a bit later because actually, yeah, I can leave it up while I talk a bit about the future and vision. And before we go into the demo, I don't know if you got already the link to the notebook that will be not really live coding, but running and
Yes.
going. So
it's in the chat on your right-hand side. If you want to follow along, please head there. It's in the chat.
Cool. So we will be so we'll be running it in a second. Before that, I'll talk maybe a bit about the package's current status and in general our plans and for the next phases, and also this is a good time if you have any specific questions. But one of the things is, as I said, we've just finished working on the initial version of the computer vision, so you can already see like the various checks we have there in our docs and how to integrate with them in the various tutorials. This is something that we felt that like while in the area of tabular, everything is relatively well defined, or well, it's kind of much more straightforward. The area of validation in vision and pictures is something that that is still kind of maybe even more unexplored land. So we were excited to start working on it, and we also got quite a lot of questions and requests in that area. So that is one thing that it's still really initial phases. So we're always happy for feedback or for any thoughts on the topic. And I would say that the two additional areas that we're planning to expand and make it more fluent or straightforward is one thing is the area of CI/CD. So we do know that some users have been in various ways, like implementing using the suite results and the check results and running it in their own CI/CD platforms, and we want to make it we want to add it like to make it much more straightforward, that you can directly integrate like any of the checks and make your own checklist and conditions, and then run it, for example, in your PRs. So that's one area of connecting it, and this is something that we feel is relevant in the area of deploying models to production. And also various things that have to do with model evaluation. So we see here that there's quite straightforward connection also between the area of initial research, of continuous integration, and of monitoring. So we have quite a few checks already in that area, like the ones I mentioned, but we feel that in those, to put in the building blocks and to also make it more fluent to, for example, start working on the metrics you want, what is relevant and what you're actually checking for, and then have it streamlined when you deploy your model to production and monitoring it over time. We feel that's something that's very relevant, and we're going to work on that, and also connect it to the area of model monitoring. So that's a bit in the kind of upcoming plans. And I will say something that I'll also be happy to send a link later, is that like any open source project, the thing that helps us the most both improve the package, whether it's by GitHub issues, feedback, feature requests, contributions, of course, both of can be documentation, which is super important, and there's lots to do there, and it can also be implementing your own code, your own checks, or elaborating its areas in the computer vision. Or there's also many questions about NLP, which we haven't yet started, but we might also hopefully be able to initiate it a bit in the future as more like together with the community, and have it kind of in mutual development. So the community is super important and helpful, and I'll say that also lots of the improvements that we have done till now, and in general the usage is mainly thanks to the amazing community. So it's really important for me both to emphasize it and also to invite you to join our Slack, to post an issue, to reach out to us on LinkedIn, Twitter. So that's in general a bit about what's there to look for in the upcoming future.
Cool. Yeah, so you answered a bunch of my questions there, but I'd love to hear a couple of questions. I guess, like first, maybe like a comment, because you mentioned like the CI/CD use case, and yeah, that seems super powerful because, you know, if you're maybe in like a slightly larger org where like the people doing the, say, like ML research and training the models have the like luxury of like not having to go through the like data labeling and processing this themselves, you know, maybe they have like a data engineering team and like a label team and people to take care of it. Like at that very like early stages of the pipeline, like this seems like an amazing way to you know, reliably like run checks and like flag things for those like more data engineering and like infrastructure teams, you know, before it even gets into like model training. Do you see that use case among your user base yet?
We do see that it's very like the point of data integrity, and it's kind of the connection point between, okay, I've got the data from the data source and the ETLs and the data engineer that usually configured and set it up, and now I started working on it, and I'll split it a bit into two because obviously there are also many challenges of data integrity and validation in general in maintaining data sources over time. So I'd say that everything that comes just before it's already kind of targeted for modeling or for data science projects. So in those areas, when it's still in the data warehouse, we're a bit less focused because we're focused on, let's say, the connection between like using the data for modeling. Yeah. But we have seen quite a few like use cases in when the data science starts working. What I'm saying is that you do see tools like Great Expectations of, okay, you want to make sure that this happens, and it's also an open source project, and when you're still in the data source, but when you start working on it for modeling and you have some, for example, like things that are relevant for your model, like label ambiguity or things that are relevant for the context of, you know, that you're working on a machine learning model, that's, I'd say, where we kick in.
Yeah, cool, love it. And in terms of like community contributions or feedback, is there a way for, I mean, ideally people would like push some PRs themselves for like checks they'd like to see, but it feels like a nice opportunity to have like a polling system where people could like upvote the checks they wanted to be added. Is there any, like, what's the best feedback mechanism for community there?
So I'll say basically everything comes down at the end either to GitHub issues or to our Slack community. We do feel that, especially in the more initial phases when people are using and thinking about like suggesting ideas, then usually talking with us, reaching out, writing a message on Slack helps start the conversation. And in general about currently we're working on the tabular and now on the initial version of the vision, so we didn't have that much of like, okay, what are the most desired features, but we will have a like more open roadmap, which will be like, well, obviously all our GitHub issues are also open, so there are sometimes people commenting or asking questions, but for specific decisions, everything will be basically accessible from our GitHub README, so you'll see there in the future that we don't have yet like a full roadmap, but only the issues that are for the next milestones.
Cool. Yeah, super interesting. And just a reminder for everyone, if you have any questions, feel free to drop them in the chat and we'll get them to share. Do you see, I'd say I have one question and then maybe we could jump into the demo. Do you see particularly strong uptake like from a particular industry? I mean, ideally, like everyone doing ML, especially in like in production, like should care about this, but I'm curious, like if there are any like industries like finance or like regulated industries where the stakes are like even higher if they mess up, especially on the data side. But yeah, curious industry wise, if you see any particular strong leaders.
So I will say that it is quite it is really quite broad, because both the types of checks and also it is really kind of everything that has to do with methodology or in these areas, and it is common problems both, by the way, because we don't have that many checks in yet in specific fairness related scenarios. So okay, you can check your segment performance. So I think that's one of the reasons, and I will say that we see also quite a bit of adoption from people earlier on in the career trying to understand the best practices and methodologies. Because I think for every check I have probably a story or two about someone that I either saw doing, whether in the research phase or a bug that we caught in production. So So I think we do see quite a lot of crave from that area to learn like what to avoid. But widely, I'd say that I maybe if I have to try to pinpoint something that's a bit more common is use cases that are actually very dynamic or active. Like for example, if you now train a super heavy model once a year, and then you're like working so long on validating the data and the model and evaluating, then probably the extra value that you'll receive from Deepchecks, given that you're spending so much time on it, is lower than if you're, for example, in a very dynamic use case, lots of models, retraining, new data coming, very dynamic data. So whether it's e-commerce or finance or marketing, so those use cases usually find the value in like using it in an ongoing manner.
Cool. Yeah, I love your comment previously is like about folks earlier in their career like learning best practices, because you know so many of these checks are like implemented like over and over again in different people in different places in different industries, and it's like there's such like unnecessary repetition. And yeah, so being able to like even, you know, browse the code in the docs and like, you know, learn, okay, like this is how like this is the right way to do this check is just, yeah, it's such a like valuable addition. But yeah, like that's enough from me. Would love to see a quick demo maybe.
Great. So yeah, so the demo it's up in our GitHub repository, and you also have the link, but you'll also be able to access it later. Some super short technical, if you are following along or plan to run it later. So what you need there is the notebook, and there's also a small utils file, just because I wanted to make the notebook cleaner and neater. So what you need is just both of them in the same folder. And well, and of course, as best practice, if we're talking about best practices, that we always recommend working on splitting your virtual environments between projects and between different experiments that you do. So so if you're working an experiment, I'd recommend to have your own virtual environment, and in there install both weights and biases and Deepchecks. And we do recommend when you install Deepchecks to add the upgrade flag, because we do work. It is in active development and lots of new features and are coming out. And yeah, so without further ado, let's dive in. So.
And just while Shira's sharing her screen again, I want to give the info to you that we are going to share the links in a follow-up email. So if you prefer just to watch, you can then revisit everything from the links in the email.
Okay, so now we're going to see a hands-on demo of running the notebook and seeing the Deepchecks results of tests on your data set. You can easily plug in your own data set or run it on the demo data set that we're going to demonstrate on now. And well, if you also have a weights and biases account, you can log in the results there. If not, you can just see them within the notebook. So I've gone ahead and ran all the initial configurations. So well, my weights and biases account is already logged in, and I have here some the name of the project that all the results are going to be logged into. And now we're going to load the data set. So this is a simple classification data set. So we're trying to classify whether an avocado is going to be sold at an expensive price or not, so a binary classification. And we have here one categorical feature. So this is how the data looks. So in order to run Deepchecks, whether it's a suite or a check, what we need is first to use our basic object, which is the dataset object, and its purpose is to have some metadata about the data itself. So as you can see here, we're creating the data set, giving it the name of the label column, and explicitly stating the categorical features. Otherwise, they will be inferred, but it's preferable to state them explicitly. And there's also some additional metadata, like if you have index column or date column that can be supplied and is relevant for some of the checks. Otherwise, they just won't run, but that's fine as well. And well, we're going to create the dataset object, and in order to run a check or a suite, we just import it and then run it on the given data. So in this case, we're running the most simple, straightforward single dataset integrity suite, which has various checks checking, well, as you can guess, the integrity of your data. As you can see here in the results, everything passed. So this is a bit boring. So But let's make it a bit more interesting, and I've added here in the utils file some noise to the data, representing a bit more real life data sets. And if we run the integrity suite now, we can also see some interesting results. So we will have the exact same checks and conditions running, since this is a default built-in suite. So so the checks in this case are pre-configured. And well, when we have a look now, we can see that some of the checks have failed. So, or some of the conditions rather have failed. So what do we have here? We have a column that has only a single value inside the data set. So if this is both in the train and in the test, then this column is probably redundant. If it's only in one of them, then this is a bit troubling and should be inspected. Anyway, we would want to know that and treat this column accordingly. We have label ambiguity, which is samples with ambiguous labels. So they have the same sample, and you can see here it has both a false and a true label. So we would want to check what's going on there. Is this something that we're aware of, or is this a certain problem? String mismatch is, there's here a categorical column. As by the way, as you can see, this is a warning. So we have like conditions can either fail or have a warning. In the suites, we have everything default conditions, the kind of best practices that are pre-configured. But of course, every data set and domain may have some specific circumstances, and all of these conditions can be added, removed, changed, both their type and also their values. So in this case, we found that there's a column that has some specific variants. So organic has it appears in 3 formats. We would probably want the model to understand that these are all the same. For example, in this case, later on in the pre-processing, we're doing some one-hot encoding. And if we would leave these like this, then obviously they would all be treated as different features, and that would be less good for the model. It will be harder for it to detect relevant relations. And in this case, we also have some data duplicates. So we can see here some more data, how many duplicates there are, and some examples. As we can see, there's also additional checks that ran and didn't trigger the conditions since they were fine. So what we can do here is we can either log all of the data integrity checks to weights and biases, or we can also decide that we want, for example, to log only the checks that didn't pass. So in this case, if we run this, I'll rerun it though the results are already logged, but we'll just see them twice. So in this case, we're initializing a run because we want all of the various checks to be in the same run. And now we'll go over all of the checks that didn't pass and save the results. So if we look, if we'll see how all these looks within the platform. So we see here all of the results. So we have this twice since we've already logged it, and now we're logging it again. And inside the runs themselves, we can see the display of each of the checks. So whether it's the conditions that passed or not, the results, and also additional data. So one moment this will load, so we can see label ambiguity failed. We can see some metadata about the results. So how the percentage of samples that failed, the columns, and some examples themselves. So in this case, the run we checked is the integrity checks that didn't pass. So we saw only them. If we'll enter a different run, then we'll see, in this case, all of the checks that were logged. So yeah, as we can see, this run's finished. So this was an example of how quickly, simply you can run Deepchecks checks even on only an initial data set. If we want to go on to some deeper investigation, so in this case we have a model. In this case we'll build a simple model for just a random forest classifier for our classification use case, and then we can see that there are some more test suites encompass the relevant checks. So for example, a model evaluation suite will have various checks, both comparing your model to a baseline, checking different parameters of the run, different results. Let's see, we have here, so we've just finished here building a model. We fit a random forest classifier, and we have And well, as you can see, it is overfitting. We can expect to see this also in the model evaluation suite. And well, the test accuracy is not very impressive, but it did learn something. And now let's see the suite results itself. So we can see here the various checks that ran. And so in this case, performance report and the different metrics and additional checks. By the way, here we also have some checks without conditions. So for example, confusion matrix for each of the data sets, train and test, and also calibration plot for each of them. So if we want, we can also run only a specific check. So for example, the performance report that we saw here above. And if we want to check, we can also just have a look at the check results by itself. So this is the value. You can see here, this is more machine readable result, and also the plot itself, just as we saw inside the suite. And well, of course, we can also log it to weights and biases. We have additional suites. So this one, let's say we want to inspect the results. We have a train test validation suite that can help compare between both data sets and see if there are any drifts or significant distribution differences or some leakage potential. And so this one accepts both data sets, and you can see the comparison. And I'll leave this and invite you to run this on your own. And and one thing that's important to note is that the checks and the suites are highly customizable. So for example, we can import any check that we want. And in order to build a custom suite, we just write the relevant checks. We can also add conditions if we want, and just run the custom suite. Of course, just like any suite and just like any check, the custom suite can also be logged into weights and biases. In this case, by the way, you see we didn't add any conditions. If you want to add condition, it would look like this, and then we'd see we can well, each check has various conditions. For example, if we show the data duplicates check, then let's see the autocomplete. Okay, so well, add condition is just for any relevant condition, for any general condition, and condition ratio not greater than, and then you can supply your own number of what is the threshold of percent of duplicates that is allowed for your use case. And well, this is just an example, but both the checks themselves many times have well, in this case, confusion matrix actually doesn't have, but the checks may have. Okay, let's demonstrate again for data duplicates. So the checks themselves have some specific variables. For example, to ignore or ignore some columns, include only some columns, how many samples of duplicates to show, and also condition, as we saw before. So both the checks are customizable, their parameters, their conditions, and of course you can also implement your own custom check and run it within the framework. And in this example, we also saw how you can implement your own custom suite. And in this case, we can see the result, the calibration metric and the confusion matrix. And of course, these can be also, 1 second, we can also log everything to weights and biases. And you can check out the results in the weights and biases project is an open one. So you can just go over the different runs that are logged in there and also see the results. So thank you. And I invite you to go over and run this on your own data. And that's it for now for the demo part.
Cool, that's brilliant. Thanks a million, Cher. This is all super interesting. Do you find a lot of people using the HTML export, to embed their plots in their own, tools that they might be sharing to share their work with colleagues?
So that's split into two. One thing is actually in a recent workshop, we were like a member of a community reached out to us and said that they're building like a MLOps demonstration of how to build your end-to-end a pipeline, and it was really cool because one of the things they did there was to open up a pipeline and then like run a Deepchecks suite and have the HTML report emailed to you, for example, if there's anything interesting or upon every new data or with whichever trigger that you want. So they integrated it, so it was a cool thing to see. And I think like things like exporting to JSON is, for example, for integrating it in various platforms or for running it like in a kind of an automatic like CI/CD. So I'd say that we see those in that use cases. In that case, usually it's like a bit more advanced usage, and you'd probably want to both adapt like your conditions, possibly your metrics and stuff like that.
Yeah, that's brilliant. Cool. Can you give it? Curious on the computer vision side. I know we're maybe running a little late, but the kind of early checks you have for your beta version of the computer vision check. Curious to hear what you're checking for there.
Yeah, so it's, as I said, many of the checks are the same types of checks, but they're implemented differently. So, for example, interesting stuff that we see there is image outliers. So if you have specific, like very bright images or very dark ones that you're not necessarily aware of, or high contrast, or so things like helping you. It's also, I would say, it's on the verge between integrity and EDA, like exploring your data. And we check for different types of drift. So, for example, if you have very different sizes of, well, in general, we look at the image's properties and the label's properties. So, for example, what is the size of your bounding box? What is the distribution of your classes? And is there differences or outliers in each of these, which you may not be aware of? Or is there a specific class in which your performance is much worse? So we did see that in computer vision in general, even for some of the, I would say, like simpler problems in tabular data of how to very easily get metrics, it's not necessarily that straightforward to segment it in an interesting manner. So these are the types of things that we try to make very streamlined in using Deepchecks for vision.
Cool. Do you have a check for RGB versus the reverse? I've fallen into that trap more than once of wondering why my model sucks, and then it's like, oh, I didn't switch the channels because it's
Yeah, so is it RGB or like CMYK or HSV or HSL or whichever? Actually, we don't have one that tries to like, we do have the way to visualize it, and then, you can see it weird, but we don't have one that tries to like extrapolate. But I mean, if you're using them consistently throughout all the areas, then it's fine. If it changes between like your train and your test, for example, or if you're visualizing it and it's incorrect, then in those areas it will actually it's likely to find a sort of drift, like in the intensities of the different channels.
Yeah, cool. That's super interesting. Brilliant. I think we're just about at time, but really appreciate you having on. Andrea, do you want to wrap us up?
Yeah. Thanks again, Cher. Really enjoyed it. Real life debugging, real life struggles, life on screen. We're going to share the link so you can run through it yourself, and like Cher said, I think it's definitely encouraging to give it a try yourself. You'll also be able to rewatch the recording. So all the resources are shared with you in a follow-up email. We'd love to see you either in the Deepchecks or Weights and Biases community. Would love to hear product feedback. And yeah, thanks to both of you. Thanks for the fantastic demo, Cher. Looking forward to more collaboration in the future. And to anyone who'd like to attend another webinar of ours, we have a live workshop, an interactive workshop with NVIDIA coming up in 2 weeks. You'll find a registration link in the email as well. We'd love to see you there. And thanks again, and see you soon.
Thanks, all.
Thank you.
Bye.